In this component of the fx-9750G2 overview, we will be focusing primarily on the run matrix and statistics applications. You'll notice them on your main icon menu as options 1 and 2. To highlight them, you can simply use the cursor and you can press execute to open and access these applications, or you can press the shortcut key in the lower right hand corner. In this case, to access run matrix, I'm going to press the number 1. Once we get in here, a lot of what you'll see and what you can do, you'll be familiar with from other calculators. Simple arithmetic is pretty straightforward. One of the features I would like to point out is the fraction key, A and B over C here. If I press 5 and then the fraction key and then 2, for instance, that stands for 5 over 2, 5 halves. And you'll get that little right angle symbol that indicates a fraction. And if I don't want to see the actual fraction, we default to displaying that fraction, but if I don't want to see that, if I'd rather get the decimal approximation, this key, the F2D key, toggles between the form of the fraction and the decimal. So to 2.5 and back. We have 2 of them showing up here because I accidentally hit execute twice. But just toggling back and forth is one option, or you can change the setup of all this by going into the setup menu by pressing shift and this key to access setup. Let me try that again, shift, setup, there we go. Right now we're in computation mode. We get our fraction results, D over C. We're in real mode, etc. There's a lot of these that affect graphs like coordinates and grids and axes and so forth. Right now we're in normal display mode, which defaults to fractions, but you can change that to fixed decimal, for instance, if you want to get a decimal. And to get back out of that menu, I just press the exit key. Anytime you're in a menu you don't want to be in, the first thing you should try to get out of it is just exit. Exit gets you out of most locations. Now what we'd really like to focus on here is the option key right here. This key will give you access to the bulk of functionality through a soft menu that shows up along the bottom of your screen. And this, while this may be new for you if you're new to Casio, it's really it'll start to make sense the more you use it. It's laid out so that each menu option corresponds with a function key below it. So if I want to access the list menu, I just press F1. The matrix menu is F2, complex numbers, calculations, statistics. If you don't see what you want here, you can access more options by pressing F6. And then even more options, and so on and so forth. And eventually you come back around to the initial portion of that menu. So we're going to go through not the entire menu because there's a lot buried in there, but we're going to go through some of the more common aspects and things that hopefully you'll find useful. We want to start out with the list menu, and some of these options we're going to skip over as well. And I just hit all clear just to clear the screen. This first list option is just a keyword. It's just a keyword to call up a list. We can store numbers into variables like A, B, and C, and those are numbers. But if you store a list, then that's referenced, instead of referencing that by the letter A, you would say list 1 or list 2. So if I press F1, it'll pull up the keyword, press the number 1, and it will tell me dimension error because I have not yet done anything with list 1. There's nothing stored there. We can convert a list to a matrix. You can compute the dimensions of a list, which generally means its length. You can fill it with the same number. If I want to make a list that's got 10 5s in it, I could do that. What I want to show you at this point is how to create a list by generating a sequence of values. And the process is how you might explain it to somebody. If you think of it in an organized fashion, you would say, let's say that I want a list of values that follow the pattern of x squared, as x varies from, let's say, 1 through 10, incrementing by 2's. You don't have to. You could put incrementing by 1's, but you do need each of these components. The pattern, what is going to alter or increment, and from what to where by what step. And if I do that, it generates those exact values. We have 1 squared, and then 3 and 5 and 7 and 9, just like we requested. If I want to get out of this screen, I can press exit and it'll pull me right back to where I was. Now, if I would prefer, I can go, I want to recall that. I press back to get into that line, and I can actually I can use this arrow here to store that value into list 1. So this is where referencing that keyword comes in handy, because I can say store that in list 1, and now when I press execute, it just says it did it. It doesn't show it to me anymore, but it stored it there. So now if I press list 1 and then execute, it'll show it to me. But more importantly, I'm going to clear the screen here. If I want to know the dimensions of list 1, well, we know that there were 5 values there, but we're just confirming that. I could find perhaps the max value stored in list 1. You'll notice the word list is off the screen, and while we can certainly go back by cycling through to access it, another nice way to access the keyword is right here in yellow above the number 1. I can press shift and then that key. So I can find the max value of list 1, which we saw was 81. There's a lot of calculations here. Augment is a way to append some values to a list. You can sum all the values on a list. Let's take a look at that. Again, I'll use shift and then this key down here. So it summed all those values, and so on and so forth. This is where all of your list computations are accessed. We also, if I want to get out of this menu again, think about what I told you. You're in a menu, you want to get out of it. What are we going to press? We're going to press the exit key. I'm going to come back to matrices in a moment. They're one of the more complicated things to work with, so I want to save those for last. But if we look at the complex menu, we have absolute value of a complex number, the argument, the conjugate, etc. I'll just do a few quick computations just to demonstrate. You have to use this particular I to stand for the imaginary I. And there we have it. If I want to find the absolute value of 1 plus 3i, I can do that. You have to be careful to use parentheses. Sometimes it's tempting not to, but you'll often get a wrong answer if you do not. We can find the conjugate. If I go to more options, we can find the real part or the imaginary part. It will just separate those out for you. We can take that number and convert it to polar form. I think that's interesting, so let's try that. 1 plus 3. Oops, I'm going to need to scroll back to get to that I. And now go to more options and again to the polar form. And there you have polar form with the radius and the theta angle. If I go into shift and setup, again we can check this. Angle set to radians. I just wanted to be sure of that, so that's what this is. This is automatically in radians unless you've configured your calculator otherwise. It looks like I lost my menu when I did that, so how do we get back to our menu? Just a reminder, option gets us in there, and we were in the complex menu right here. Let's see what else we've got. We can convert back to a plus bi form, and since this was my last answer, it will, if I press this key, it will pull up my last answer and say reconvert that, which should get me right back to 1 plus 3i. Moving on, getting back out of this menu, I press exit. I want to look at some of the calculations available to us. A lot of these are calculus based, but not all are. For instance, if I would like to find the derivative of, let's say, 3x squared. Right here I should really explain this key. Right underneath alpha you have x, theta, and t. And if you're new to our graphers, that's our independent variable key. Often it's x, but sometimes it's theta if you're in polar form, or t in parametric form. So rather than always call it the same thing like x, we will say independent variable because it can vary. So if I want 3x squared, and I want to find the derivative of that function at the point 4, where x is 4, and there you have it. It just uses numeric approximation methods. This is not a CAS calculator. It does not do any symbolic manipulation, and it could not give you just the derivative without evaluating it at a point. While we're at it, let's take a look at the integral. This is going to be very similar. 3x squared again, let's say. Oops, I lost my squared. 3x squared. And let's say I want to integrate that between 0 and 3. It just naturally assumes that x is our variable. And again, I double-clicked exe by mistake, but 27 is our answer. No big surprise there. While we're in here, another thing I want to point out to you in the next menu screen, we have summation. This is pretty handy. This summation is going to work just like the sequence of values earlier. You give me the pattern. So in other words, x squared as x goes from 1 to 10 by 2s. Same exact thing. The pattern, the variable, from what to what, by what step. This is just like sequence. Log of any base is pretty handy. If I want the log base 4 of 8, I can compute that, and you don't need to use any fancy formulas. It just pops that right out, which is really nice as well. Backing up by pressing exit, I want to take a quick look. We'll skip over statistics because we're going to look at the statistics application. A lot of what's there is available here if you want to do a quick one-off computation. But generally, if you're really using a lot of statistics, it's easier to go into that mode first. If I press F6 for more, we'll take a quick look at the conversion menu. I'm going to press all clear again just to clear the screen. Here, there's a variety of things you can convert from length to other, between length and length, area and area, volume, time. What else do we have? Temperature, velocity, mass, force, pressure, energy, power, a lot of stuff. We'll keep it really simple. I'll just show off length really fast. Actually, let me back up a second. We have to put our number in first. So let's say I have 5 millimeters. I'll press 5. I'll go into length. And millimeters are right here, number 4. And then this dark shaded arrow means it's the conversion arrow. I want to convert from 5 millimeters to, and I need to pick a different length. I could do like angstroms. This looks, I'm guessing, femtometers. I'm going to go over here. I'm going to press the right arrow. We can move left and right back between these. And I'm going to convert this to feet, let's say. You can press the number or you can highlight and press execute. So from 5 millimeters to feet, and once you have that set up properly, you press execute one more time, and that is 5 millimeters expressed in feet, 0.0164, etc. feet. So there's a quick look at the conversion menu. It's all pretty much the same as that. Backing up again, we have hyperbolic functions, which I'm not really going to get into very much. I do want to show probability really quick. Something like factorial is really nice, just 8. Let's see, where does that go? There we go, 8 factorial. You just have to type it in as such and it'll show you your result. Permutations and combinations are awfully nice. So for instance, if I have 5 items and I want to pick 2 of them in such a circumstance where order matters, then it's that straightforward. We have 20 combinations. I shouldn't say combinations. We have 20 different ways to take 2 from 5 when order matters. Whereas if we want to do a combination, it's going to be very similar, only because in this case order is not important. We actually have less interesting results or less variable results. Let's see, one last thing I want to show is the random menu. Some of the things you can do: create random numbers. When you do that, it will just generate a random number between 0 and 1, just some decimal randomly. What I really like is random integers. This one you can create a random integer between one number and another number. So from 1 to 6, for instance, will be like rolling a die. And what's really great about this is you just keep pressing execute and you keep rolling and rolling. That's pretty amazing. 2, 6, 2. There we go. We finally got something else. Just random chance, of course. What's even better, if you have a use for it, is that I could potentially create a random set of numbers. Like if I want to roll from 1 to 6, and I want to actually generate 5 rolls between 1 and 6. When you do that, it will create all of them. It'll put them all into a list. You can even store that output to a list using this right arrow storage function, or storage feature, if you so chose. You can do random normal distribution, random binary, a list of these random decimals. Those are all options that you can explore further. Now that we've taken a look at those features, let's see, we've also got some numeric calculations like absolute value, integer truncation, greatest integer, which I'm trying to remember, floor or ceiling function. It's not coming to me at this very moment, but you can play around with that. Fractional part, rounding, GCD, LCM. These are all nice features for you to explore. They're pretty straightforward. Modular arithmetic. Let's see, angle computations. We've got, you can force things into degree, radian, or gradient mode. And we've got, that's right, engineering symbols. This is somewhat interesting as well. For instance, if you wanted to work with 5 millimeters, then this is just setting it up as 5 times 10 to the negative 3rd meters. It's just comparing it to some base value. So it's automatically putting on the appropriate scientific notations. We got milli, micro, nano, pico, femto. And on the flip side, we have kilo, what's this, mega, giga, tera, peta, or peta, I'm not sure how you pronounce that. Exabytes, for instance, would be, I think, 10 to the 18th. And then these keys keep whatever value you have. In this case, 5 times 10 to the negative 3rd. But you can, by pressing this, it will change that to 5,000 times 10 to the negative 6. It's no different value. It's just changing the representation, right? It's increasing this and decreasing the associated exponential format, so it doesn't really change. And so this increases the number ahead of the exponential, and this decreases the number ahead of the exponential. If you don't have much use for it, well, that's not a problem. You'll know who you are if you need it. We have the ability to save a picture of a graph you created, or to capture the screen. We have some logical operators, and we have some functional memory storage. That's most of the time I've seen that used as part of a program if you're working with programming. And then again, you have time value money, which you can use here. Things like simple interest, compound interest, but again, I'd recommend you use the application dedicated to that. Before I forget, I did say we'd come back to matrix, so I'm going to, while we have some matrix calculations you can do here, I'm going to press exit and get all the way back out to the main menu, because this is where you really want to enter your matrix. So for instance, if I want to enter it as matrix A, I will select that and press execute. Before I do, one important detail is that the you reference a variable like this, the letter A. You reference a list by list1 or list2. You reference a matrix by saying mat A or mat B. So you really need to be careful about this, because you can't just call matrix A A. A is the variable A, and matrix A is matrix A. So if I go in there, press the dimension, let's say 2 by 2, and press execute each time, and execute one more time, we can now add some values in. Let's say 1, execute 6, execute 4, execute, and negative 3. So execute. So we'll put all those in. Now that that's done, I'll press exit, exit one more time, and I want to go into option. I now want to get back to my matrix calculations. So matrix A now has that information I put in there. And if I want to reference it, I can call it mat. This is the keyword, so mat A. We'll call that up, mat and alpha A. Execute, and it pulls it up for me. Exit to back out of there. But if I want to find the determinant of that matrix, now I do determinant, this key, again of matrix A. Or I can find the transpose of matrix A, or I can augment matrix A. Maybe I want the dimensions of matrix A. Over here I can do row echelon form or reduced row echelon form. So because we set this up to be linearly independent, if I find the reduced row echelon form of, oh, we don't have matrix available here, we don't have that keyword available. Once again, just like with list, you can scroll to get it, or you can pull this MAT right above number 2 by doing shift to matrix A. And again, because we know it's linearly independent, we expect it to reduce to just an identity matrix. Let's see. So that seems to be all of the important matrix computations. The most important thing I wanted to show you was that you probably want to enter a matrix right this way before you get into that menu. That said, we want to take one look at one more thing. We want to go to statistics. Earlier, when I generated that list, I stored it in list 1. It's here under list 1. So I think just for the sake of time, I'm going to show off a few quick, neat tricks. Like I can enter values into list 2 just by typing them. But you can also enter a function or a formula. For instance, I can say that I want list 2 to be everything in list 1 doubled, for instance. And to do that, I just highlight the top of list 2 and I say shift, make that list 1 times 2. And it will just double everything. Kind of a handy little feature if you want to do any computations on a previous list. The main reason I did that is I just want to quickly show you a scatter plot, and I wanted to populate that list. So you'll notice at the bottom we have our typical soft menu, graphing to perform calculations like regressions, statistical tests and intervals, and distribution. So for graphing, we have 3 different graphs available to us, 3 different stats graphs, graph 1, 2, and 3. You can graph them independently, or by using this F4 select option, you can graph some of them simultaneously. You also can do some setup in here under the set screen. Right now we're on setup for stat graph 1. To change that, I can change it to stat graph 2 or stat graph 3. I'll go back to stat graph 1. I'll leave it as a scatter plot in list 1 and list 2. But I'll show you really fast that you can choose not only from scatter plot, but an NP plot, if you know what that is, pie chart, histogram, box plot, bar chart, some less common ones I'll skip over, and you can even do some regression graphing once you've computed that. I don't really want to get into that at the moment. I will take a quick look. You can adjust the frequency if you have such a thing as a frequency list, the mark type, etc. But I already have it set as a scatter plot. That's fine with me. I'll get out of this by pressing exit. And again, that was graph 1. So I just, to graph 1, I just press that. And there we have it. We already expected that to have a slope of 2 since I just doubled all those points. But if I wanted to compute a regression, I do that right here under the calculate menu. So F1 will let me do a linear regression based on x, or x squared or x cubed regressions, more options, log, exponential, lots of great stuff, logistic, and back around. I'll just do a regular linear regression. You can do a ax plus b or a plus bx form, depending on your preference. Since my background tends to be as a math teacher, I'm going to go with this. And in a huge surprise, I find that my slope is 2 and my intercept is 0. No, that's not a surprise at all, is it? Since I put in such perfect numbers. Oh, kind of nice feature. You can copy these results nicely and easily by pressing F5. You pick where you want to store them, what graph function. If I want to store them in Y1, I just press execute, and they're stored. And then you can draw it in as well. Once more to get out of here, press exit a couple times. There, we get back. Oh, maybe one more time. There we go. You can calculate regressions from here, but usually we would recommend you to graph before you compute a regression, since usually you want to see what your data looks like. You can perform some statistical tests, intervals and distributions. If we look at a statistical test, let's say a z-test, a one sample z-test, it defaults to a list of data, a list of values that it will perform a test on, but in this case, to simplify our lives, I'm going to pick a variable, and I'll say that let's say we want to do not equal to, so a two-tailed test. Let's say our null hypothesis is a mean value of 50. I'm just making these up. Let's say, oh, you know what? I don't want to do a z-test. I want to do a t-test. It's not really a big deal. But you notice it keeps the same values, though. So once you program them in for one, it'll stay there until you've replaced it. Let's say my sample mean is 45, and my sample standard deviation is 20. Again, I'm just making this up. And just for demonstration purposes, 50 values. Now, you can just compute that by pressing execute, and it'll give you your p-value and your t-statistic. But what's also nice is if you scroll down, whoops, I scrolled down a little too far. You can also draw this, and I really enjoy drawing it just because it gives you a nice visual representation. And then from there, you can find the p-value if you wish, or pressing exit. Let's see, let's try that again. Draw that. P-value. Yeah, so if you want to access that again, you'll have to back up and redraw it to get the t-statistic. But in any case, it's nice to be able to get that p-value and that all on the screen at one time. Pressing exit a bunch of times. Intervals are going to work the same way. I'll do again a one sample t. You'll notice it already populated it with exactly the same numbers we had before. So you're not going to get anything new or exciting here. Same exact information basically, just with our interval. And if I go to a distribution, we have a normal distribution, t, chi-squared, f, a lot of stuff that if you're using it, you'll know what it is. And just really quickly, I'll show you a binomial CDF. Again, you can do a list of values, but I tend to prefer using variable. So let's say I have a 4-choice true-false quiz, and I want to know the chances of getting 3 or less correct out of those 4 questions. Whoops. Assuming that I have a 50% chance of guessing on each one, and execute, and there we have our results. So, okay. That being the case, I think we've covered the bulk of what I want to cover. We will, of course, be revisiting in some future sessions. We'll be looking at more at graph, dynograph, table, etc., all these other icons. But I think taking a half hour of your time is enough. So thank you for your attention.